dimensions topic which comes under units and measurement chapter. So last class also we are discussing this dimension. It is a continuous part of that dimensions. So here I am going to write a acceleration dimension. How we have to write dimension for this acceleration? See, you should write the formula for acceleration, that is the rate of change of velocity with respect to time. So I written meter per second square. Now how will write dimension? See if there is kg, no means no kg means 40 m raised to 0, and length it is meter given, no, l raised to 1, and second square if you write l raised to 1 or else simply l also can write. So understood, l means l raised to 1 and second square it is t. So time, no, so unit of time it is second square, like that. So here t raised to minus 2 will write, because it is a down and it go up, it will become minus 2. Okay. Similarly force, what is the formula? Mass into acceleration. Mass SI unit is kg, acceleration SI unit is meter per second square. Now we write dimension for this one. Kg means already it is m raised to 1. Okay, m it is l raised to 1, and second square it is t to the power of minus 2. Okay. Next one is momentum. Okay, mass into velocity, right? So mass into velocity, again kg, meter per second. So kg means what? M raised to 1, and meter it is L1, and second it is t to the power of minus 1. Okay, it's a simple. Okay, so can you try for this work? So again work, if they ask for dimension for work means, before what you have to remember? Formula. Okay, force into displacement into cos theta. So what is the dimension for force? Again you should remember dimension of force. What is? Mass into acceleration, this one. So already we have written for force, no, m raised to m raised to 1, l raised to 1 and t to the power of minus 2 into displacement means it is the length, right? L. So means meter. So that is L. Okay. So now overall you can write here, right? So what you can write overall? M raised to 1 and L. See here it is 1L and here it is 1L. How will it? L square and t to the power of minus 2. So again write dimensions for power. Power is equal to what? Work by time. Again remember the formula, work by time. What is the dimension for work? Again formula, force into displacement. I already written dimension for work, that is m raised to 1, a to the power of 2 and t to the power of minus 2 divided by time is t. So overall you can write, so m raised to 1, l raised to 2 and t to the power of minus 2. Now here on if we go, it will go upside and will become minus 1 again. So what is t to the power of minus 3? Okay, so simple. It will go up, so that we will get t to the power of minus 3. This is the dimension for power. Okay, you should remember the dimension for all these quantities. Okay, so first thing is what you have to remember? Formula. Then you can easily write the dimension for that physical quantities. Okay, so now what they will give in your exam, sometimes they will give quantities, physical quantities, and ask to write dimensions. Sometimes what happens, they will give a dimensions and ask to write this physical quantity. Okay, so now we will see that how we have to write the physical quantities of for this dimensions. Okay, physical quantity, give a dimensions. Okay, so for example, m l raised to 2, t raised to minus 2. Okay, so now how will write? So first thing you should remember some basic physical quantities dimension. So then you will write this one. So now first thing I write m means K means definitely it is a kg. Okay, next I will write only one L and t to the power of minus 2, and I will write L here. So now what happens here? M means kg, no? Huh? L means meter, and this t square, no? So second square will get. So what is the SI unit you got now? That is force we got now, that is force. Next here it is only L we can write, it is a displacement, right? What is force into displacement formula? What is the force into displacement? Last we have written no, force into displacement, that is work. So now we got work, the physical quantity for this dimension we got, that is work. Okay. So similarly another I will write. What I will write? M L square t to the minus of 3. Okay. So now what I will write now? See. First I will write M. Again, yeah, if it is M means it is kg. I will write L. Okay. L square. L square means meter square. I will write T square. Okay. I will write 1 by T. So here M L square T to the power minus 2. So I have split if I split this one, I got this thing. So this thing means, again, see, you should not write this one, you should remember this. Okay. So what it is? Work. Again it is time. Work by time. So what is the physical quantity work by time? It is power. Likewise, they will give dimensions. They will ask to write physical quantity. So you should write like this, physical quantity. Okay. Sometimes okay, they will ask to write important question. They will ask to write kinetic energy and potential energy dimension. So write kinetic energy is equal to potential energy dimensions. I will write kinetic energy 1 by 2 mv square, right, is equal to potential energy formula. You write mgh. So you write 1 by 2. M means mass m, and v square. See here, v means what? Meter per second, no? So L t to the power of minus 1 square. Okay. So next m, again m, gh means meter per second square, no? So that L to the power of minus 2, h means L. So now leave this numerical value, can write m L square t to the power of minus 2 is equal to m L square t to the power of minus 2. See now, so these two are equal. So kinetic energy and potential energy dimensions are equal. So if left hand side dimension is equal to the right hand side dimensions, so you can write it as a homogeneity principle. So what we can write, it is homogeneity dimensions. Okay. So this is a very important question. So please read the rule about this dimensions. In this topic, it is very important about dimensions only. Please concentrate on dimension topic. Okay. So thank you very much.